Okay, hello everyone. So in this part of the video, okay, we're going to go through your homework, okay, for chapter 9, the second part where we find unknown angles using trigonometric ratios. Okay, so just a quick recap. So previously in the previous chapter, chapter 8 in Pythagoras theorem, we learned how we link three sides, okay, of a right angle triangle together, meaning if you know two of the sides, you can find the length of the third side, okay, for any right angle triangle, okay, using Pythagoras theorem. In trigonometric ratios, okay, instead of three sides, we look at one angle and two sides. So if you have maybe one angle and one side, you can find the other side, or you have two sides, you can find an angle. Okay, so using trigonometric ratios. So in the previous part of the earlier part of the chapter, okay, we are given one side and one angle, and we find the other side. Okay, on this part of the chapter, we're going to be given two sides, and I'm going to find the angle. Okay, so without further ado, okay, let's move on to the questions. Okay, there is a total of 6 questions that are assigned you guys for this part of the chapter. So from exercise 9.1, is question 4, 7, 9, and 10. In exercise 9.2 is question 9 and 10. Okay, so 9.1 is more of the slightly more direct questions, while 9.2 is more of those applications questions where there's a context, there's a story or scenario to the question. Okay, those are the more typical kind of questions, okay, that will appear during exams and so on. But of course, I will still have like 1 or 2 questions which lay some foundations, some basics for you. So let's start with the first one, question 4. Okay, question 4, okay, over here they ask you to find the acute angle theta in each of the following. Okay, the word acute means less than 90 degrees. So over here, when we are looking at finding angles, okay, we are assuming that all the angles here are less than 90 degrees. Okay, when you go to upper secondary in maths, you will start to learn that when we are finding these angles, actually they can go beyond 90 degrees. Okay, so but for now at secondary 2, everything will just be less than 90. Okay, so let's begin the first question. Sine theta equals to 0.5. So sine theta equals 0.5. You want to find the angle theta. You need to get rid of this sine. So how do we do it? We use the sine inverse. Okay, how do we use sine inverse? Okay, you see over here, if let's say I have sine theta equals to 0.5, I'll write as theta equals to sine inverse of 0.5. So you key into a calculator, take note, look very carefully. In your calculator, there is your sine, cosine, tangent. There's also your sine inverse, cosine inverse, and tangent inverse. Okay, the one with the small like -1, okay, as a power. So when you key into a calculator, make sure you choose sine inverse 0.5. Okay, this should give you 30 degrees. Okay, take note, make sure that your calculator is in degrees mode, not in radians mode. Okay, then after that, we go to part B. 7 sine theta equals to 6. You realize that now I have a 7 over here. Okay, how do I apply my sine inverse? So when you are doing a sine inverse, first thing to take note is always throw any of the other numbers or to the other side, then you apply the sine inverse. So in this case, I have 7 sine theta equals to 6. I so-called throw the 7 to the other side. So this is your basic algebra. To so-called throw this to the other side, you divide both sides by 7. So left-hand side divided by 7, this will disappear. Right-hand side divided by 7, you get 6 over 7. So sine theta equals to 6 over 7. Now you have all the numbers on one side. The other side is just your trigo ratio of sine and theta. Okay, then you can apply your sine inverse. So theta equals to sine inverse 6 over 7. Key into your calculator, you get 59.0 degrees, okay, corrected to 1 decimal place. Okay, so previously in maths, generally if you have any answers, they are not exact numbers. Okay, meaning like when you do the calculation, you realize that it is a whole chain of numbers. You usually round off to 3 significant figures. But for angles, okay, we always round off to 1 decimal place. Okay, please take note, for angles is 1 decimal place. Okay, we move on to part C. 11 cosine theta equals to 9. So same thing. Okay, my 11 I throw to the other side, I get cosine theta equals to 9 over 11. Okay, once you have that, you just need to apply your cosine inverse. So theta equals to cosine inverse 9 over 11. Okay, so after that, you just key that into a calculator. Cosine inverse of 9 over 11 is 35.1 degrees. Okay, corrected to 1 decimal place. Next, I have 2 cosine theta equals to square root of 2. So through to the other side, cosine theta equals to square root of 2 over 2. Okay, then you apply cosine inverse. So theta equals to cosine inverse square root of 2 over 2. Okay, your answer is 45 degrees. This is an exact number. I move to part E. Part E, 5 tangent theta equals to 13. So tangent theta equals to 13 over 5. So theta equals to tangent inverse 13 over 5. So you can see more or less the same thing. All you need to do, bring all the numbers, okay, to the other side, leaving on this side only your sine, cosine, or tangent of your angle. Okay, then after that, you just need to apply the inverse, okay, and you can get the answer. Key into a calculator. Okay, in this case, 69.0. And for the last one, 3 tangent theta equals to 2 over 5. So you divide both sides by 3. 2 over 5 divided by 3 is 2 over 15. So tangent theta equals to 2 over 15. Same thing, theta equals to tangent inverse of 2 over 15. You get 7.6 degrees. Okay, so also correct to 1 decimal place. Okay, now that's it for question 4. Next, we move to question 7. Okay, question 7 is a very important question when it comes to building your foundation or the basics, okay, to really understanding, okay, the whole topic of trigonometric ratios. Over here, they not just only ask you to find angles, they're also asking you to find length, okay, of x. So they are applying both what you have learned earlier in this topic and also what you have just learned for this topic. Okay, so let's begin, okay, with the first question, part A. Over here, I have triangle ABCD. Okay, you can see that this is right angle over here. So ABC is a right angle triangle. ACD is also a right angle triangle. Okay, so you need to find x and theta. So which one can I find first? So let's go back to the understanding of trigonometric ratio. I say again, trigonometric ratio links one angle and two sides. One angle and two sides. Okay, as long as you know any two of these three things, you can find the third one. So in this case, if I look at this triangle ACD, there's theta, there's x, there's 8. So I only know one thing. That's insufficient for me to find the rest. But if I look at, like, for example, triangle ABC, I know one angle, I know one side, there's this third side of x that I need to find out. So I know two of the three things, I can find the third thing. Okay, so in this case, let's take a look. I have this angle 55 degrees. Okay, these are the two sides that I'm going to use. Okay, so I have 4 over here and x is what I'm trying to find. So based on this angle, taking reference from this angle, x is my opposite, BC. Okay, over here 4 is my adjacent. So if I have opposite and adjacent, okay, the trigo ratios that connect the opposite and adjacent will be tangent. Okay, because tuaka, so toa, TOA. So opposite over adjacent. So tangent 55 degrees will be equals to opposite, which is x, over adjacent, which is 4. Okay, so tangent 55 is equals to x over 4. Okay, so we solve that. Tangent 55 is x over 4. So x will just be equals to 4 times tangent 55 degrees. Key that into a calculator. Okay, you should get 5.71 cm. Okay, so take note, usually if there's some in between, okay, your upper sec teacher will ask you to do 5SF instead of 4SF. Okay, but when you're finding the answer itself, okay, it will be 3SF. Okay, but intermediate, we usually do 5 instead of 4. Okay, next, now that I have known what is x, can I find theta? Yes, okay, I know this side, I know this side, I can find my angle theta. Okay, so two sides, one angle. So which trigo ratio should I use? I need to look at what are the two sides that's involved. So if this is my reference angle, CD, okay, over here is my opposite, and x is my adjacent. So it's still opposite and adjacent, so I'll still be using tangent. So tangent theta will be equals to opposite, which is 8, over adjacent, which is x. Okay, so let's go back to the question. Yep, so tangent theta equals to 8 over x, where x is my 5.713. Like I said, if you're doing this, okay, use 5 decimal place, but preferably use the full thing. Okay, if you can use the full thing, that will be ideal. Okay, because there's no rounding off, your value will be the most exact. Okay, so instead of 5.713 something, you write as 8 over 4 tangent 55 degrees. That will be the most accurate. Okay, so after that, you just need to take your tangent inverse. So theta equals tangent inverse of 8 over 4 tangent 55 degrees. Key into a calculator. you should get 54.5 degrees, okay, corrected to 1 decimal place. Okay, next I move to part B. So part B over here, I have two triangles again, ABD and BCD. Okay, so I have X and theta, which is what I'm trying to find. If I look at BCD, I realize that I only know this. I don't know these two, so not enough information to do anything. If I look at ABD, I know one side, I know one angle, I can find the third side. So re-emphasize again, trigo is one angle, two sides. You just need to know two of them, you can find the third one. Okay, so in this case, I'm having 50, 17, and X. So which is the trigo ratio I need to use? That's the next step. Okay, you look at what is the angle and the sides involved. So if this is the angle, this side is considered opposite, and this is my hypotenuse. Okay, so opposite and hypotenuse using Tuakaso, you know that will be so. Okay, so SOH, sine is opposite over hypotenuse. So this means that sine of 50 degrees will be equals to 17 over X. Okay, so sine 50 equals to 17 over X. Let's take a look. Yeah, okay, so sine 50 equals to 17 over X. So X will just be equals to 17 over sine 50. Okay, key that into your calculator. Okay, you should get 22.2 cm. Okay, so with that, I come back to the question. I know that this is 22 point something. This is 32. So now I know these two sides. Can I find the angle? Yes. Okay, I know these two sides. I know I want to find the angle. So which trigo ratio should I use? So let's take a look. With this angle, this is considered the opposite of the angle. And this is still the hypotenuse. Okay. So opposite and hypotenuse, you also be using sine. So sine theta will be equals to X over 32. Okay, opposite over hypotenuse. So sine theta equals to opposite 22, okay, over hypotenuse of 32. Like I said, ideally, if you can, write down the full thing, okay, before any rounding off. So you can write as sine inverse 17 over sine 50 over 32. Okay. So this should give you 43.9 degrees. Okay, after that I move to part C. So part C, okay, the triangle looks something like this. Okay, I have X and theta that I need to find. So I want to find theta. Okay, do I have enough information? Theta will be looking at triangle ABD. I don't know this, I don't know this, I only know this. So not enough information. I need at least two pieces of information. Okay, but if I'm looking at triangle ACD, I know 54 degrees, I know 6. Can I find X? Yes, I can. Okay, so I know one angle, one side, I can find the third side. Next step, decide which ratio to use. Okay, I have 54 degrees here, I have 6 here, I have X. So based on this 54 degrees position, X is considered the opposite and 6 is my hypotenuse. So same thing, opposite and hypotenuse will be using sine. Okay, so SOH. So sine of 54 degrees will be equals to opposite, which is X, over hypotenuse, which is 6. Okay, so sine 54 equals to X over 6. Okay, then X will just be simply 6 times sine of 54 degrees. Okay, key that into your calculator, you should get that X is 4.85 cm. Okay, so once you have found the X, okay, are you able to find theta? Yes, now you can find theta since you know X, you know 10. So you have two pieces of information, you know these two sides. Can you find the angle? Yes. Okay, so next you need to decide which trigo ratio to use. You look carefully, this is theta, this is opposite of the theta, and this is the hypotenuse. So same thing again, we're using sine. Sine theta equals to X over 10. So write that in. Okay, so sine theta equals to X over 10, where X is about 4.85. Okay, then you will know that theta will just be sine inverse of 4.85 over 10. Okay, like I said, if you're going to use rounded off value, make sure you use at least 5SF. So you should use 4.85 for something, okay, the 5SF. Or ideally, it'll be better if you just straight away write the full thing down over here. So meaning sine inverse of 6 sine 54 over 10. Okay, then there's no rounding off issue. Okay, your answer should be 29.0. Okay, the rounding off issue comes when sometimes because you use a rounded off value, you key into this, you realize that your final answer might be a little off, okay, from the correct answer. Okay, and then that's where you may lose some marks just because of that. So the best is if you use the full value. If you the full value is a bit hard to key in, like as there's more calculations, it gets more complicated. What you can do is you use the 5 significant figures value. Okay, so 5SF. Okay, your upper sec teacher also teach you using 5SF. Okay, next we move to part D. Okay, part D, this figure looks kind of the same as C. Okay, so let's take a look. I need to find X, I need to find theta. Okay, so in this case, theta, I only know this is 7. I don't know what is X, so means I need to find X first. Okay, so X, if I look at triangle BCD, okay, I know this angle, I know this side, I can find X. Next, you need to determine which ratio to use. Okay, based on the position of this 51 degrees, this is considered opposite, this is considered adjacent. So that will be your tangent. Okay, so TOA, tangent 51 degrees is opposite over adjacent. So tangent 51 is X over 4. Okay. Tangent 51 is X over 4. So X will just be 4 times tangent 51. Okay, so you key that into a calculator then. Okay, over here they start to use 5SF. So that's why I'm not sure how come they sometimes 4, sometimes 5. But okay, we will use 5, okay, for in-between values, okay. But to answer the question, you still do it to 3SF. So in this case, 3SF is 4.94 cm, okay. Once you find out what is X, okay, you are ready to find theta. You know this is 7. You know this is whatever value this is, 4.9 something. Okay, then next you need to determine which trigo ratio to use. This is the angle involved. This is opposite of the angle. This is adjacent to the angle. So it will be tangent again. So tangent theta equals to opposite, which is X, over adjacent, which is 7. Okay. So tangent theta is X over 7, or you can say 4 tangent 51 over 7. Then you take the inverse, so theta equals to tangent inverse 4 tangent 51 over 7. Okay, then you should get about 35.2 degrees. Okay, sometimes even you use 5SF or what, it should not make much of a difference. Okay, in terms of your final answer, it should be more or less accurate. Okay, but of course ideally it will be you use the full value lah. Okay, next we move to part E, another very similar layout, okay, of the triangles. So I have X and theta. So far the questions is you need to find X first, then you can find the theta. Okay, but for this question is slightly different. I'm unable to find X, okay, because over here I don't know what is this angle in total. I know this is 8, so I know enough information to find X directly. But I can find theta first. If you look at triangle ACD, okay, I know this is the angle, I know this is 6, I know this is 8. Two sides, one angle I can find. Okay, so to find this angle, okay, and you once again decide which trigo ratio to use. This is opposite to the angle, this is adjacent to the angle, so you'll be using tangent. Tangent theta will be opposite over adjacent, so tangent theta is 6 over 8. Okay, so tangent theta is 6 over 8, so theta will just be tangent inverse of 6 over 8. Key into your calculator, okay, you should get 36.9 degrees. Okay, take note for angles is 1 decimal place. Make sure you write your degrees, okay, that's the units. Okay, once you know that this is 36.9 degrees, are you able to find X? Yes, okay, you know this angle is 23 plus your 36.9. You know this side, this is 8. So you know one angle, you know one side, you can find the other side over here. Okay, once you find the other side over here, just take this side minus away 6. Okay, you should get X. Okay, so basically tangent, tangent, yes, okay. So before you even decide as tangent, you need to know which trigo ratio to use. If this is the angle, this is considered opposite, this is considered adjacent, so yes, you use tangent. So tangent of this angle, which is 23 plus 36.9, will be equals to opposite, which is X plus 6, over adjacent, which is 8. Okay, so let's write that down. So tangent, okay, of the two angles add up, okay, equals to opposite, which is X plus 6, over adjacent, which is 8. Okay, so next you just need to cross multiply over. So X plus 6 is equals to 8 times tangent of the angle. Okay, so once you find this, is x will just be this minus 6. Okay, so you key into your calculator, x should be 7.78 cm. Okay. Last but not least, we move to question part F. So question part F, okay, we have two triangles over here. Need to find x, I need to find theta. Can I find x? Not enough information, I only know one angle. I need to know at least one more side, either this side or this side. Okay, so not enough information. Okay, but can I find theta first? Yes, I know this side, I know this side, I can find theta. So two sides, one angle. Next, decide which trigo ratio to use for this particular angle and these two sides. This is the opposite to this angle and this is the adjacent to this angle. So we'll be using tangent. Tangent theta will be equals to opposite over adjacent. So it will be 10 over 14. Okay, tangent theta is 10 over 14. So theta will just be tangent inverse of 10 over 14. You key into calculator, get about 35.5 degrees. Okay, so yeah, you have this angle. Okay, so once you know this angle, next you need to find x. You still realize that not enough information. I need to know at least BD or I need to know CD. Is there any way to find CD now? Not really, but is there a way to find BD? Actually, yes, because BD is the hypotenuse of triangle ABD. Okay, there's more than one way of doing it. Okay, I can use trigonometric ratio to find this. Okay, I know the angle here. I can use one of the side together to find this, or I can also use Pythagoras theorem. Okay, so for this particular topic, okay, it's also strongly related to Pythagoras theorem. Sometimes during exam, there might be cases where you can use either trigo or either Pythagoras theorem to solve. Okay, because all are working in right angle triangles. Okay, so but in this case, let's say we use Pythagoras theorem. You know that 10 square plus 14 square will be equals to BD square. Okay, because Pythagoras theorem tells us that the sum of the square of the two sides, the two shorter sides, will be equals to the square of the hypotenuse. Okay, so in this case, let's come to the question. Let's see how they do it. Yes, they do that. So BD square will be equals to 10 square plus 14 square. Okay, you need to write that this is by Pythagoras theorem. Okay, because you are using this relationship. Okay, you need to show that you understand what you are using. Okay, so key to take note which the workbook answers always missed out is that BD is equals to plus minus square root of 10 square plus 14 square. Okay, when you take square root, make sure you do a plus minus. And when you take plus minus, you need to remember to reject the negative. So in this case, BD is square root of 296. So you need to write bracket reject negative 296. Okay, so once you know what is BD, okay, you'll be able to find x. Okay, which ratio do you use? If this is the angle we are looking at, this is adjacent and this is the hypotenuse. So if adjacent and hypotenuse to our car, so we use car, okay, cosine of 28 degrees will be equals to adjacent over hypotenuse. Okay, so it will be equals to BD over x. Okay, so cosine 28 degrees equals to BD over x, where BD is square root of 296. So in this case, they did not go and solve it out because in the first place, the question there asks you to find what is BD. So I don't need to write it out in full numbers. And by writing down the square root of 296, I use the full value without any rounding off. Just like how just now I said you can use the tangent something or the sine something without using the rounded off value. Okay, so to find x will just be simply square root of 296 over cosine 28 degrees. Okay, key that into a calculator, x is about 19.5 cm. Okay, so we have done with question 7. Like I said, question 7 is a pretty important question. It covers quite a lot of the basics. Okay, so now we move to question 9. Okay, so for question 9 over, sometimes question may not be so straightforward, meaning you can't see the right angle directly. The right angle triangle directly. You need to draw out your own right angle triangle to help you with the solving. So in this case, I have a trapezium ABCD, okay, where AB is parallel to DC. Okay, tell you that BC is 7 cm, DC is 4 cm, and angle ABC is 45 degrees. First, they ask you to find the length of AD. You'll be wondering, how do I find the length of AD? So going from the thinking of, okay, I need to make my own right angle triangle, what I can do is from the point C, you can draw a line down. Okay, since here is right angle, here is right angle, when I draw a line down perpendicularly, I will form a rectangle. Okay, so it will look something like this. Okay, draw a dotted line down. Let's call this point N. This will be right angle. Okay, because here are both 90, here will also be 90. So if this is a right angle triangle, so BCN, this is a right angle triangle, you want to find what is AD. And AD will be the same as NC over here or CN over here. Okay, because they are rectangle, so these two should be the same. Okay, so if I know this is 45, I know this is 7, can I find this? Yes, one angle's two sides. This is the angle. These are the two sides. I know two of them. I can find the third one. Next, decide which trigo ratio to use. If this is my angle, this is considered opposite. This is hypotenuse. So opposite and hypotenuse, we use sine. Okay, so sine 45 degrees will be equals to opposite, which is Cn, over your hypotenuse, which is 7. Okay, so sine 45 degrees is Cn over 7. Okay, so some of the lines over here, let's look through quickly. So first, they ask you to draw a perpendicular Cn, okay, from C to AB, so which is what they did. And they say that Cn is equals to AD. Okay, then, yeah, in this triangle, we have set this up. Sine 45 equals to Cn over 7. So Cn will just be 7 times sine 45. Okay, key that into a calculator, you get about 4.95 cm. Okay, so you know that Cn is 4.95, AD also be 4.95 since they are rectangle. Okay, so means this and this will be the same. Okay, next they ask you to find the length of AB. So the length of AB is across here. Okay, how do you find the length of AB? Like I say, usually when you find this kind of length, there's two ways. One is if you are finding a shorter length, you will take a longer one minus another one to get the shorter length you're looking for. If you're looking for something longer, then you might need to calculate certain smaller parts and piece them together. In this case, you're looking at something slightly longer. I have AB. Okay, since ANCD is a rectangle, so if this is 4 cm, this will also be 4 cm already. Okay, just like how just now, if I know this, I also know this. So if this is 4 cm, to find AB, all you need to do is to just also find what is BN over here. Okay, to find BN, same thing. I know this side, I know this angle. So one angle, two sides. I know two of the values. I can find the third value. Which trigo ratio should I use? BN is adjacent to 45. Then BC is your hypotenuse. So adjacent hypotenuse will be cosine. So cosine 45 will be equals to BN over 7. Okay, cosine 45 is Bn over 7. So Bn will just be 7 times cosine 45. Okay, key into your calculator, you should get Bn is 4.95. Okay, so once you have found that Bn is 4.95, are you able to find what is the length of AB? Okay, so if this is 4, this will also be 4, okay, because it's a rectangle. This is 4, this must be 4. You know this is 4, you know what is this, you can find the total length of AB. Okay, so 4.95 plus 4, you get about 8.95. Next, we move to part C. Part C, they ask you to find the area of this trapezium. Okay, so quick recap on the definition or the formula, okay, for area of trapezium. Okay, area of trapezium is given by half times L1 plus L2 times H. Okay, so what is L1, what is L2? This is L1 and this is L2. So your L1, L2 are the pair of parallel lengths. Okay, so you take half times the sum of these two times the height. Okay, so this is the height. The height must be perpendicular, okay, to the parallel lines. Okay, so once you know that, you know this is 4. L2 is what you have just found for AB. H is what you have found for AD. So it seems like you have all the info you need. Let's get to it. Okay, so half times 4 plus 8.95 times 4.95. Key into your calculator, get 32.0. Okay, next we move to question 10. Okay, question 10, I have triangle ABC, okay, where CD is perpendicular to AB. Okay, they tell the angle CAD, this angle is 35, AB is 13, CD is 6. So they ask you to find the length of AC. So this is the side they ask you to find. So AC is part of triangle ACD. Okay, so to find this, one angle, two sides, I know this is my angle, I know this side, I know this is the side I'm trying to find. So next is determine which trigo ratio to use. Based on this angle's position, this is considered opposite, this is considered your hypotenuse. So opposite and hypotenuse, if you go and look at Tuakaso, that will be so. Okay, so sine 35 degrees will be equals to opposite, which is 6, over your hypotenuse, which is AC. So sine 35 equals to 6 over AC. Okay, so doing some rearranging, AC will just be 6 over sine 35. Key into calculator, get 10.5. Okay, once you have found that this is 10.5, they ask you to find what is this angle over here. Okay, so to find this angle over here, I know this is 6, I know this angle, I need to either know what is the length of BC or the length of BD. Okay, so this might be quite tough, okay, but this is actually not too difficult, okay, because you know that this is 13, you're able to find what is AD. Once you find AD, you can find BD. Okay, so by taking 13 minus this. So to find this is the angle, this is the opposite side, this is the adjacent side. So opposite adjacent, you use tangent. So tangent 35 is equals to 6 over AD. Tangent 35 is 6 over AD, so AD is just 6 over tangent 35. Key into your calculator, you get about 8.57. So now you know that this is 8.57. You can take 13 minus 8.57 to find what is BD. Once you know what is BD, you know this is 6, you can find your theta. Okay, so this is the part where BD minus away this to find, as in to find your BD. Okay, so you take 13 minus this, you get this. Okay, so once you have this, next you know this side, you need to find an angle. So two sides and one angle. So in this case, this is considered opposite, this is considered adjacent, so you use tangent. Okay, so tangent is opposite over adjacent, so it's 6 over whatever you have found here. So tangent theta is 6 over this. Okay, so I think they skip a step. Okay, take note. Okay, so over here, theta equals to tangent inverse 6 over 4.431. Okay, so you want it to be more accurate. Okay, instead of 4.431, okay, you can write it as 13 minus 6 over tangent 35. This will be the most accurate full answer. Okay, so you key into a calculator, you should get about 53.6. Okay, so that is question 10. Okay, so we move on to exercise 9.2, where is the application questions. Okay, to finish up 2 more questions. Okay, we start with question 9. Okay, so over here, TF is a vertical building. I have 2 cars A and B. They are 38 meters apart, same level. Okay, so this means that they are all horizontal. They are one straight line. Okay, so BT is 60. FBT is 46 degrees. Find the height of the building. Okay, so in this case, to find the height of the building, there's 2 triangles over here that shares the same height. Okay, of course, I can't use ATF since I don't know what is this. I don't know the angle. There's not enough information. But I can use triangle BTF. I know this angle. I know this side. So one angle, 2 side. This is the angle. This is the known side. I can find this side. You need to determine which trigo ratio to use. Based on this angle, this is the opposite, this is the hypotenuse. So opposite and hypotenuse, you use sine, okay, to akaso. So SOH, sine 45 degrees is opposite, which is FT, okay, over 60. Okay, so sine 46 degrees equals to, or TF over 60. So it just be, TF will just be 60 times sine 46. Key into your calculator, you get 43.2 meters. Okay, so now you know that this building is 43.2 meters tall. Okay, so the height of the building is 43.2 meters. Once you have this, they ask you to find what is angle FAT. So this is the angle they ask you to find. Okay, so one angle, two sides means you need to know either this side, this side, this side, two of them. Am I able to find AT? Not really. Am I able to find FT? I already found it already. Am I able to find AF? Kind of. I know this is 38. I can find this, so I can make use of this side. Okay, so I'm going to use AF and FT. Okay, so for this side, I know 38, but I'm missing this. Okay, so to find this, same thing, I know one angle, I know this side, I can find what is this side. So based on this angle, this will be considered adjacent. This is the hypotenuse. So adjacent hypotenuse, I use cosine. Okay, so ka. So cosine of 46 will be equals to BF over 60. Oh, over here they decide to use Pythagoras theorem. Okay, that is also possible. So they know this, they know this, they try to find this. Okay, you should get the same answer. Okay, but the key thing to note, okay, why I will not encourage you to do that is because let's say if you got this part wrong and then you use the wrong answer and do a Pythagoras theorem to find another wrong answer, this wrong answer can cause more implications because subsequently, let's say your wrong answer is too big or too small, you key into certain things in your calculator, it ends up as an error, you cannot get an answer, then this will affect you. Okay, but if you are able to do so, try as much as possible to use the given value. So I would recommend you to use 46 degrees and 60 to find this, okay, using cosine. Okay, but if you are using Pythagoras theorem, this is 60. So BF square plus TF square will be equals to 60 square. Okay, so you know this 60. So 60 square minus TF square will be equals to BF square, which is what they wrote over here. So 60 square minus the other square. Okay, then they take square root. Same thing, you need to write by Pythagoras theorem. Okay, because this does not just come before you learn Pythagoras theorem, you don't know that you can do this. So you need to state that this is Pythagoras theorem. Okay, and when you take square root, take note over here, the textbook always forgot, you need to write a plus minus when you do a square root. Okay, and then you need to reject the negative. So over here, BF will be 41.68, bracket reject negative 41.68. Okay, so after you have found your BF, okay, you know the height of the building, now you are ready to find this angle FAT. So sometimes during exam, the question will not be as straightforward as one step you can get it. You might need to do 2 steps before you can get it. Okay, so in this case, I know this, I know this, I want to find this angle. So which are the 2 sides involved? Based on this angle, I want to find this is considered opposite, this is considered adjacent. So based on opposite and adjacent, I'll be using tangent. Okay, tuakaso tua. So tua is tangent of FAT, which equals to TF, okay, the height of the building over the adjacent, which is AF. Okay, so you key that in. Okay, so the height of the building is about 43.16, okay, which you have found over here. Okay, over 38, which is what is given, plus BF, which is what I've just found. Okay, so if possible, it'll be nice if you can key in the full value, meaning instead of 43.16, you write 60 sine 46 over 38 plus square root of blah blah blah, or in this case, now we're using cosine, you use the full value. Okay, but if you can't use the full value, try to use 5 SF, don't use 4. Okay, your upper sec teacher will teach you as 5. Okay, then next you just need to do your okay, so over here they decide to solve this before they do the tangent inverse. Okay, either way, like I said, try to use the full value. Don't round off too many times. Sometimes you round too many times, you realize your final answer might not be correct anymore. Okay, so your angle FAT should be 28.4 degrees. Okay. So last, question 10. Okay, so over here in this diagram, I have A, B, E, okay, three points on the first floor, so they are a straight line. Okay, they have AC and AD, okay, tied from point A to the second floor and the third floor. Okay, they tell you that AC is 4.6 meters long. Ask you to find what is AB and find BC. Okay, so this one will be very simple. Okay, you know this is 40, you know this is 4.6. You can find what is AB. So one angle, two sides. Which are the two sides involved? Based on this angle, this is considered adjacent. This is considered hypotenuse. So tuakaso will use ka, adjacent over hypotenuse. So cosine 40 will be AB over 4.6. Okay, so all you need to do is solve. So AB will just be 4.6 times cosine 40. Okay, key that into a calculator, you get about 3.52 meters. Okay, take note of the units. Okay, make sure always write your units. Okay, next, BC. So BC, same thing, you use this angle and this side to find this side. So based on this angle, this is considered opposite, this is hypotenuse. So opposite and hypotenuse will be sine. So tuakaso. So sine of 40 will be equals to BC over 4.6. Okay, so BC will just be 4.6 times sine 40. Okay, so BC will just be 2.96 meters. Okay. So once you have this, next they ask you to, they tell you that given the heights between the consecutive floors are the same. What does this mean? This means that BC will be equals to CD. Okay, because this is first and second floor, second to third floor. So if the heights are the same, means BC must be same as CD. We should have already found what is BC, so these two should be the same. They ask you to find angle CAD. Which is angle CAD? This is CAD. So it's this angle over here. So please take note, one of the common mistake, people will think that, oh, this is same as this. Since this is 40, then this angle must be 40. Ta-da, done. Not so easy. Okay, so let's do some calculations to see for ourselves. Okay, what will the final answer be? So I know this is the angle I'm trying to find over here. Okay, I know this side, I know this side, I can try to find this angle. Okay, so this side will just be 2 times of that. Okay, so it will be just 2.96 plus 2.96. Okay, and then this side, which is AB, which I just found, is about 3.52. Okay, so this will be 3.52. So based on this angle that I'm trying to find over here, this is my adjacent, this is my opposite, so I'll be using tangent. So tangent of angle, okay, take note, when I'm looking at angle, I'm looking at angle BAD. So this is the angle BAD. So this is the angle. Okay, so tangent of this angle is equals to opposite over adjacent. So let's write that down. So tangent of, okay, instead of BAD, they write DAB, is the same thing. Okay, it's opposite over adjacent. Okay, so like we said just now, okay, because they are same height, so BC equals to CD is just 2.957. Like I say, if possible, instead of writing 2.957, you write the full thing. You write 4.6 sine 40 plus 4.6 sine 40 over 4.6 cosine 40. So that will be the full value before rounding off. Okay. And then you do your tangent inverse. Here they skip a step. So actually this will be, okay, if I write the full step out. Okay. This will just be angle DAB equals to tangent inverse all these values. Okay, key this in your calculator, you should be able to find the angle here. Okay. So once you found this angle, that's not the end. Okay, so this angle is DAB, which is the full angle. You are trying to find CAD, which is just this smaller part. So you need to take DAB minus 40. Then you realize that when this minus 40, you only get 19.2. It is not 40. Okay, so take note, we are doing this kind of questions. Do not just assume. Okay, you need to do the calculations and see it for yourself. Okay. Okay, if not, I think that is all, okay, for this part. If there's any questions you're not sure, please let me know. I might have gone a little faster, okay, but because there's video, you can always rewatch. You can pause, you can slow down, okay. This for you to control. Okay, otherwise, yeah, that's all for me. Thank you. Bye bye.